Today, I'm going to talk about the second category of compounds and how to name them and write formulas. The last time I saw you a couple weeks ago, I taught you about the binary ionic compounds. And so that's a metal plus a nonmetal. And you use the periodic table here to determine what the charge of your metal and nonmetal is. So we go by the general rule. Oops, no, I don't want that one. Do I want? No. Where is it? That one? Whatever. That group 1 is +1, group 2 is +2, 13 is +3, and then we go from 15, 16, 17, -3, -2, and -1. So that was last week. And no, sorry, the week before last. And I mentioned that these guys in the middle are going to be a different category. I'm going to talk about those today. So this category, the way that we name it is called the stock system. I don't know where the word stock comes from, but it's it's still a binary compound. So it still has 2 elements. And those elements are still a metal and a nonmetal. I don't know why my M looks so weird. Oh, it's my mouse. A metal and nonmetal, but the metal has more than one possible charge. And this is for the transition elements or the transition metals. So let's go back here and I'm going to go ahead and zoom in and let's take a look at, for example, manganese. Now, the reason why I really like this periodic table, and I think I uploaded this to GC so you can have access to it if you don't have one at home. But the reason why I really like this one is because it gives you all of the possible charges in the upper right-hand corner. So if you have a formula that includes one of these from the middle and you look in the upper right-hand corner and you see more than one number, that automatically tells you that you have to use this method to name the compound. So how this works, I'll just give you an example and I'll use the manganese. So let's just do MnCl2. Okay. So same thing we did before is you look at the first element and you determine the charge. So you'd come here and you look at Mn and you're like, oh, holy crap, there's 4 possible charges. There's +2, +3, +4, +7. Which one is it? This is how you figure out which one it is. You have to look at the negative nonmetal that it's paired with. So you determine the charge of just one of the chlorines. So again, you come back here, you find chlorine. Chlorine is in this group. So chlorine has a charge of -1. So I'll just change to red here. So chlorine has a charge of -1. But there are 2 of them for every 1 manganese. So if I take -1 and I multiply it times 2, I get -2. Now the whole, if I erase that part to make it easier to see. All right. So up in the upper right-hand corner, you don't see anything, right? So like last time, when we look at Cl as an ion, you see a little negative in the corner. There is nothing here for MnCl2 because just like the last compounds, when you add the total plus and the total minus, it has to be equal to 0. So I'm just going to put an equals 0 sign over here. So then there's a missing number here. So you have to think what number -2 equals 0. So you should say, well, it's +2. Right? +2 - 2 equals 0. Then you look at the formula and you say, okay, well, how many Mn are there in the formula? And you see there's no number here. So that implies that there's only 1. So Mn is +2. Okay, so you go back here and you're like, yep, that makes sense because there's, oops, that's totally in the wrong place. There is a +2. So it can be +2. So in this case, it's +2. So what do I name this thing? You do it exactly the same way that I taught you before, but you have an extra step because they have more, I keep circling the wrong thing, more than one possible charge. So when you name the compound, you have to indicate which of those 4 charges this compound represents. So you still write out the name of the element, and you still write the second element name, but it has to end with IDE, so it's chloride. But now, in between, just after the name of the metal, you put a Roman number to indicate which charge it represents. So in this case, it's a 2. So I put a Roman number 2. And just to remind you, if you don't remember all of your Roman numbers, 3, 4, 5, 6, I think 7 probably is the highest you go. So 1 is I, 2 is 2 I's, 3 I's, 4 is IV, 5 is V, 6 is VI, and 7 is VII. So you use these Roman numbers right after the name of the metal, and that indicates the charge. So this number indicates the charge of the metal. Okay, so if I give you another example, but we go the other way, if I give you the name and you have to find the formula, let's see, I'll do vanadium V oxide. Okay. My handwriting's so sloppy today. Oof. Okay. So vanadium and then in bracket V oxide. So you recognize V as being 5. And again, this number tells you about the metal. So I can write out V plus 5. Oxide comes from oxygen. And I go back over here. Find oxygen is here. It's -2. Come back here. Whoop. So the charge on oxide is -2. If you do the long mathy way, you try to find the lowest number that is divisible by both 5 and 2. In this case, it happens to be 10. So you need 2 V's and you need 5 O's. So your formula is V2O5, or like I said, super easy, no brain way. You take the 5, whoop, and the 2, whoop, and you swap them out. Either way, you get the same answer. But this whole system is using the Roman number because your metal comes from the middle section here where you've got more than one charge. I will tell you that I like this periodic table, like I said, because it's got the numbers in the corner, but also I want you to pay attention to the fact, like, look at zinc here. Yep. And cadmium. Yep. Silver. Yep. There's only one number in the corner. Therefore, for these metals, even though they're in the middle, they're in this box, this area, because they only have one charge, for these, you don't have to use the Roman number because there's only one possibility. Sorry, it looks like zinc is being 2 and 3. Circle stops there. So I have some practice. So first thing, I'll do a couple of examples and then I'll have you guys do some examples, okay? So I'll do these 4 and then I'll give you the other ones to do. I think there's like 5 or 6. And then I'll do 4 of these and I'll have you do the rest. So I'll do, it's the same thing on both sides because I usually print this out. I'll do this 4 and this 4. Okay. So copper oxide. First thing I want to do is find copper so I know what the symbol. So I know what the symbol is. I mean, I know what the symbol is, but you guys probably don't. So can anyone find copper? If you do, can you tell me what number it is? I'll give you a hint. It's in group 11. Anyone? Is there anyone left? Am I talking to myself? Ooh, whoa. Yeah, okay. See you. Thanks for saying in the chat. Okay, it's right here. So I know the symbol is CU, and right away I am looking at the charges +1 +2. So I go back to my sheet and I say, okay, which one is it? Nah, it's 2. So I write Cu +2, and oxide, again, is O -2. They're already equal, so my formula, CuO. Okay, remembering that we still, it's still the same thing when you write the formula. When you put the positive and negative together, they have to be equal to 0. That doesn't change. Okay, next one, manganese, which we just had, which was Mn. This 3 tells us that manganese is 3. Now I have to go find selenide. Boop, boop. So that's going to be a non-metal, which means it's over here. Where does selenide come from? You see it? Remember, it's going to be a different name because when it's an ion, it ends with IDE, but the beginning, the first half of the name will be the same. In group 16. Here. Yeah. So group 16. Oh, because I cleared it. -3, -2, -1. Group 16 is -2. So we've got Se -2. So again, super long mathy way, the lowest number that is divisible by both 2 and 3 is 6, which means Mn, you need 2 of them. Se, you need 3, or just swap. Okay, next, copper 1 oxide. Well, we already know copper is Cu, but now the charge is +1. Oxide is still 2. So now you need 2 coppers for every 1 oxygen to make it equal. Okay, again, just swapping. Nickel. Come back to the periodic table. Nickel is right next to copper. So Ni, because of the Roman number, it's +2. And iodide. Does anybody remember the charge of iodide? Is it -1, -2, or -3? You have a 33.333% chance of getting it right. Come back over here. There it is. -1. So I-. This time, you need 2 iodide for every 1 nickel. So it's NiI2. Also, be careful when you write your formulas about your capitals and your lowercase, because capital N with a small I is nickel, and then you need 1 big I for iodide.